courageous people that stayed until almost the end. There is one more little session that we want to have to discuss a little bit more informally and as a group of bright people, a little bit about the future of DREAM. One thing I can tell you, this I was counting, was the DREAM number 14, the 14th conference that DREAM has. Probably is going to be the last of its nature, because we are going to be evolving into a different way of doing the gathering of the best performers. We still don't have clarity on how. But so, if nothing else, you've been present in the last DREAM conference of its kind. Hopefully, we will continue to get together in some other format. So the reason I want to do this is, like, my feeling is that DREAM is special in the sense that, as opposed to other competitions like Kaggle, which is great, and others that are going around, is that we have tried since the beginning to act with a sense of community and collaboration. We try to do that, not always achieve that, but we want to do that. And one of the things that I was thinking is, going forward, is how we can act a little bit more as a big group of people that are interested in the same kindred spirits, that are interested in the same end goal. And one of the things that I believe is needed in this world of AI and foundation models is that we need more validation of these models. We need to understand what the F are these things producing, where they fail, and where they are really strong, right? But those boundaries, those decision boundaries of where are the limits of these models, we don't know very well how to interrogate, right? And so I was thinking, and I want to invite your opinions as well. Try not to be too shy, right? Is that, we can divide the crowd that we usually we call this crowdsourcing, benchmarking by crowdsourcing. We can try to divide and make the people who are, for example, experts on synthetic data to create synthetic data sets to push these foundation models, for example, as single cell or LLMs. And another group that may be even experimental, may have data to push these models from a perspective of a ground truth that is actually measured. And there are many other ways that we can imagine of how to ask questions. For example, what happens with a single cell-based foundation model? Foundation in the sense that they are very generic, and then you will refine to do, for example, specific cell type or perturbation of this or that sort, right? But the question to you guys is, do you think there will be an interest in a community that will be probably much bigger than this, if we advertise it well, to organize ourselves as a community to test a subset of well-chosen foundation models in order to understand its limitations and its strengths? So that's my question to you.
I have a question, Gustavo. So all the previous DREAM challenges, you picked up a biomedical problem you want to solve, and machine learning was the tool to achieve this. And now you want to take a tool and get the people to challenge that tool. So I see two problems with that. One is that tool is going to change every single month. Like if you look at ChatGPT and Gemini and whatnot, it's crazy. The pace of innovation is really, really fast. And second is, do you really believe that LLMs are so important that we should dedicate a whole DREAM challenge on benchmarking them? It's a question. I don't know. Everybody's kind of throwing away their LLM. Don't clap. I'm trying to be controversial here, but I think because that's a drastic change from the previous DREAM challenges. But it's almost a societal thing now. everybody's using LLMs,
Yes, yes.
right? So
I will answer briefly, but I want everybody to chime in. I mean, totally. The reason why I work for a big hospital, and everybody is trying to use this for patients in one way or another. So I feel that there is a need to benchmark in order to not do any harm. There are 800 or so, 850 AI-based um, medical devices approved by FDA. Every day we will see more. So I feel that Dream is well equipped to do that. But the other question that you ask is very good. It's like we usually had asked for models, not for benchmarking question. And the reason is that these models, I don't think that ChatGPT is so important. What is important is that we are starting to use them. But they are so expensive to train that we cannot ask for foundation models to be submitted for us to benchmark. First, because we don't know how to benchmark. But second, because they are very expensive. So that's my take on your question, which is well taken and very important.
So I think I have a comment. I think something.
just to be fair.
Yeah, I think something important is two things. One is you don't have to build foundation models, right? You can use code that's already there and just fine tune for specific tasks. That's one thing. The other is, I think you really have to divide by fields, right? For example, in imaging, it's very clear that pre-training and using them is very useful. That works really well. I think in single cells, for drug predictions, I think that's not so clear. And I think the problem, from what I've seen, is that, in a bit what I was saying, is there's no real benchmarks in the sense that people do cross-validation however they want. They use the folds to their advantage. So all the problems that we've seen in part why Dream is there are happening. But because of the speed of things, people just put out all these papers. So I do think that it's not about benchmarking LLMs. It's about finding good data that can, just like with imaging, that can tell you how good they are or not. And I think that's still kind of in the philosophy of Dream. So that if we pose a problem that's good enough, there's going to be models like that are going to be fine-tuned for specific tasks. And the problem is that each paper now is just publishing and adding new fine-tuned tasks. If it's a DNA paper, some papers try to predict gene expressions. For example, bird-trained DNA models are not very good at predicting gene expression. They're very good at learning motifs and things that are on DNA. But if you don't give them any data, the one-shot learning is basically the same as pre-training on DNA. Single cells, there's been like a flurry of also bioRxiv papers showing that linear models are just as good as the big single cell ChatGPT embeddings. You don't need any of that for now, right? And I think there's still work to do on the pre-training. You should do more than just use DNA if you're using BERT. Why don't you use Hi-C? Why don't you use methylation? Why don't you use, there's a lot of things that need to be done. So I do think that there's space for a Dream-like. Now, the problem is, what is the data set? Why is it so special? What is the difference between a normal Dream challenge and now, well, one of the differences is that these things are benchmarked on 10 tasks that are very different, right? It's not the same to predict binding sites, to predict gene expression, to predict cell type, but they're doing all these things at the same time. And so that's one of the problems is it's already very hard to have an unpublished data set. How are we going to get 10 or something that really, and same thing for molecules that really can assess in an objective way the models. What's happening right now is people don't even care about that. They just want to show they're better. Right? It's a little bit what's happening with when Gemini, when the new models, they're always better, right? They're always better than the others. Even, every company, even IBM will, produce a new model that's going to be benchmarked on some specific fine-tuned tasks where they're going to be better. But that's part of and this is what's happening, right?
So that's the thing.
They're always better even when they're not.
Yeah, or you sub-select the data sets and the cross validations and the and the metrics and the tasks that you need to do, and that's a problem. And this is really happening. I mean, this is happening under our eyes. So how do you
Well, that's the question. I think that there are maybe smart ways. For example, I think I was telling you, right, Benjamin, that there was this this benchmark created by, this is low, small scale. So this is the problem of what I'm going to tell you. But there is this Nigam Shah from Stanford decided, because he is in the IT department in Stanford in the medical hospital, and he's seeing all these people trying to use these kinds of things, right? They are not yet approved. And so if you look at ChatGPT, for example, and Gemini and so on, they are benchmarked on medical examinations that doctors take. And they are typically multiple choice, and the question contains all the information to give the answer. But that's not what doctors really experience in their offices using LLMs. So the question that Nigam asked is, he had 15 physicians creating 15 scenarios, not 15, I think 1,000 scenarios, like a number per physician, that were linked to electronic health records, that were given to the LLM, and then the result of the LLM was contrasted with the actual result of that scenario created by physicians, and LLMs were ranked and evaluated in terms of their accuracy. And in general, there were of the order of 1,000 examples that were trying to assess this. And the scenarios were created individually by these 15 physicians. So is there something like that, using some sort of maybe data sets that people are collecting in the individual labs, that would create sufficient number of questions that would push our understanding of the limitations of, for example, one of these single cell foundation models, to ask questions about single cells, right? Now, I don't know exactly. We have to define one medical problem or biomedical problem, and we have to define exactly what we want to do. But once we do that, we may have enough creativity in the community to ask questions whose answers we know, but are not necessarily using the training of this foundation model. So what do you guys think? Do you think this is crazy, it's impossible, or something worth considering?
Do you think, so I know the DREAM Challenges platform has hosted several challenges, and several of those have been data sets that have electronic health records, for example. Just talking about the example that you were just mentioning, could you collate all of those together as part of one challenge and have a DREAM challenge of challenges with LLM models? That way you have.
I think within the class of challenges, probably yes, like what Benjamin was presenting earlier. So all these drug sensitivity challenges and so on. There may be something there. There may be, though that data is, I don't know whether that data was used to train any of this. Anybody is working on single cell foundation models or any foundation model at all, or what are, yes?
No, not directly, but so I just wanted to comment on.
Yeah, go ahead.
The Birney group, come on.
Do you want to?
Well, yeah. I mean, it's intimidating. So yeah, I agree with. I think it makes sense to be problem-oriented, because in academia it's easy to publish if it's flashy, but what we actually care about is solving the problems. So the point to be problem-oriented, it's very important, independently of the method. But I think the main limitation is still in the data sets. For example, in the medical field, I know in Cambridge, where I'm from, where I work, Microsoft Research was trying to develop a sort of foundational model, if you want, or a specialized language model for interpreting radiology data. And it was interesting. I mean, the techniques and the algorithms are there, but the data sets need to be manually curated and processed. And it achieved still relatively good results, but the data is the limitation. As far as I could see, I don't know what you were referring to, the biomedical applications of these are not yet there to be used in the real world because of the data sets. And so we would probably lack the data sets. I mean, I'm just giving a comment here. And also, another point that I wanted to make is that some of these applications that I've seen for foundation models or that use a similar architecture to language models are used on problems that are, I don't see how they can be mapped to a language model. For example, DNA language models. In proteins, I think it's sensible to think about a language because there is a sequence of amino acids and this will directly influence the structure and the function. But the DNA is more like there's many regulatory codes and it's more like different languages, different foreign languages being pasted together and compressed. And it, like, I don't see how the transformer architecture can be used to model all of these. And if you then see each individual task, for example, transcription factor binding, gene expression, sequence annotation, whatever, there will be much simpler models that do the same things much better. For example, BPNet that was mentioned today, that is a very simple model, but it's extremely powerful and extremely interpretable. Yeah, so anyway, these are, I just wanted to comment on this. But I do think that the task-based approach that is focused on a problem that is relevant to be solved, then yes, that is totally on board on that.
Tony?
No, go. I talk too much.
Sure. Yeah, a few thoughts. One is, I guess you were getting at this. Foundation models means a lot of things in the different modalities these days. I think John Ma was the most recent one to complain that every model that's pre-trained on 5,000 samples is labeled as a foundation model these days. So everything's a foundation model. It's not just large language models on text. But they do exist for nucleotides and proteins and images and what have you. So if you zoom out to that scope, I could see that coming together and picking some set of foundation models for the community to really dig into. And maybe nucleotide models are where the most attention is needed most desperately first, because there's disagreement about whether they work and offer something over simple models. I'm agreeing, not just relying on your testimony for that. So in that sense, I think it could make a lot of sense. I also wonder if finding people who really understand the models and some specialized aspect of the application and domain might be a way to avoid needing a lot of new data generation. So we work with protein language models a lot, and there's usually the same set of evaluations done when people develop new protein language models. Like the ESM team showed they can predict protein structure contacts, so that's a standard evaluation that's done. But Tata Bio came out with a new benchmark right now that was pretty different from what everyone else was doing. And it's all about neglected species and the tree of life. They're focused on diversity of genomes and looking at archaea and all these other ways to evaluate protein language models. And they can include nucleotide level models. And you see different strengths and weaknesses of models by pulling in different tasks from existing public data. So with that mindset, maybe that would be the approach, is like, what's the class of model to target right now? And in this community, we might have the right expertise to think about how to probe the models in a very meaningful way and start to gain traction that way. And maybe my final thought that at least some people will agree with, staring at some of them, is I'm kind of less excited for the community to spend a lot of time crowdsourcing and putting a lot of work into evaluating whether the commercial models are any good. Like, they're closed and we don't have access to them and we don't know entirely what they're trained on, and they are being used. So I understand why we want to understand their limitations, but it somehow seems less exciting for me to spend a lot of academic labor digging into those versus the models that are open and available. But that's where I would be more interested in spending the DREAM community's effort.
So when it comes to language, right? So I guess the most basic application would be something where you have a clinical database that is very well structured and curated, right? And then now you're saying, well, can I reproduce this, or can I get something similarly better if I were to have an AI going through all the health records? Can I reconstruct that? So for instance, at the perinatology research branch, where we collected information through, in pregnancy on 30,000 patients, we have a structured database with what we think it's relevant, and it's curated in some way, right? So now if I would have access to the PDFs of all those records, right, that would be kind of application to work with only pure language models, right? Because they're about extracting knowledge from language, right? So who has something like that and I think there would be value there, like, right? So there would be value there to benchmark the different models, but that would be something pure for language. Now, when it comes to
creation of a model out of this kind of data that you're mentioning.
Yeah, so let's say then you can compare a model based on the structured database to predict some outcome relevant to that type of data, and then some word embeddings extracted by the LLM. So that would be something. But I'll close that parenthesis there. Now, coming from a field like genomics, where we all look at gene expression, RNA, protein, and so on, I still feel that actually our biggest what we are missing most is really how do we leverage past data. Whenever I try to make a model in pregnancy for one particular data set, it's like we always start from zero, and it's just like crazy because many other people generated some other data, and we are not using that, we are not leveraging that. So maybe I would think, can we somehow work together on taking the GEO data sets, for instance, just take gene expression in general, right, and make something like a transformer model that would try to collect all we know about gene expression in general, let's say, and then can that kind of information help in boosting performance when you take a small data sets and you're trying to make a predictor? But if you're to use some of that prior knowledge, would that be better? This is kind of how I think about it. Like, if you go, that would be the last thing to say here, is like, if you want to do a linear discriminant analysis, right? The linear discriminant analysis would require you to know the variance covariance of those predictors. Well, if your data set is small, you can't do it well here. But what if we leverage all that is known in the past? Is it for that particular type of sample or for that, that remains to be seen. But that's something that I would think would be worthwhile doing.
I think RSGDREAM, I forgot the university, is doing something like that. It has like 1 million gene expression profiles, is building those vast variation onto encoders.
Well, so that's the thing. I mean, can we have a set of problems or to do something like this help?
Yeah, so basically, if I understand correctly, the previous DREAM challenges were fairly opportunistic. You had a data set, you had a cool question, and you asked the community. Then there was the idea challenge, where you kind of put that on its head, and you basically ask, if you have a cool question, what would be the DREAM data set to answer that question? I know in the same vein, you're basically asking, we have all those applications and want to create the DREAM benchmark for those models to be proven useful or not, right?
For one or two, not for all. But
yeah. But So I agree. We should focus on a few specific themes, but it could be a very expensive business. And I'll tell you my idea here. So you want to go single cell? Why not creating single cell profiles before and after a drug or genetic perturbation? Boom, here you have your ground truth. You give the baseline single cell, and you ask the question, can you predict what's going to happen to all those single cells? People are doing this on a very, very small scale. And that's where all those foundation models pretend they're working super well because they selected one benchmark out of 10 and they show great performance, right? What if we do like 1,000 of those? Then there is no way to cheat anymore. Like the context will be so diverse that the weaknesses and strengths of those models will be more apparent. But we need industry almost to kind of finance that kind of profiling. I really like your idea of people building those clinical databases, because we do that as well, right? We have this big cancer initiative called the Marathon of Hope, where you literally have clinical fellows spending hundreds of hours to look at those charts and transcribing those charts and those beautiful epic medical records and put them in a nice database we can use for research. We're talking about millions and millions of dollars and man hours spent in that. So we have the end product, we have those databases. How many of those people actually kept all the PDFs and all the clinical notes? We don't, like we throw them away. We're only interested in the end product. We need to be interested in the raw data, keep that raw data so we can compare the two. But then I agree, like it would be amazing to see how MenPalm and Gemini and ChatGPT can actually do to create fairly complex medical records from those very, very messy unstructured data. But that, again, if you want to create it from scratch, it's going to be millions of dollars of clinical fellows going through all those records. Can we tap into existing initiatives to aggregate? But then the problem is those are probably the most sensitive data you can imagine. So it's going to have to be federated, like model to data kind of way. But I would be uber excited by an initiative like that.
You want to? Yeah, go ahead.
I just have a comment.
Yeah.
I mean, I think everybody knows this, but I think we're in the problem of like there are these silos of data, silos of models. You have to know where to go to get these, and there isn't a map telling you where to go if you want a pre-trained model or a data set that is so similar to yours that you can use it for training or use it for validation or follow-up. There isn't.
Your orchestra does something like that for cancer data, right?
Yeah, it's super limited, but yes, and it's only public data set. We cannot share on orchestra things that are private by definition. We don't have the mechanism, we don't want to deal with that. But yeah, that would be an example. If you have those data nutritional labels, you can actually even have tools to compute some similarity metrics with your data set against others.
Yeah.
And you are saying
It's-
maybe more general.
Yeah, more general, but like having a resource or kind of like, how computer science was before there was Google search. Like everything was so siloed, right? You had to know people to find exactly what you wanted until everything was in an online digital internet library. And now you can find everything everywhere. And there is no such resource for genomic data. It's even worse for exposomics data. It's really worse. And a lot of this data is sensitive, so people can't just share it. Like we couldn't just share all of our data without all sorts of agreements and stuff.
You could probably share aggregate statistics, so people could send queries without seeing the data.
We do that through an application. So the I2B2 that we have the ex post results, summary results that are all public that we share. And I work for the government, so we use taxpayers' money, so we have to share a lot of our results as long as we protect the participants' privacy. So, but a lot of other institutes don't share their results or their models. We are also required to share our code, which we do through GitHub and other things. So that's one problem. I don't know what the solution is to have like some sort of resource where you just go and literally search for what you want, and you find the right data set or the right model or the right foundation model that you were describing earlier. And then the other problem that you talked about, like, it's once you have everything tabulated, then models can run. But getting there from PDFs, from clinical notes, that's 80% of the work. And we don't have public models or anything like that, or some code or pipeline that is shared to do that. And yes, we keep reinventing the wheel. Every time we do an analysis, we are reinventing the wheel. Someone's already done this somewhere, but they're not sharing it. So, or we can't find it. We don't know how to find it. So then we have to write everything from scratch. And we spend a year doing an analysis that shouldn't have taken that much time.
As you said, people are so focused on the end product, which is how I need my database. They forget about the process.
Yeah.
Because that database is just one. There will be another one and another one, and 1,000 others. And if people don't focus on the process, we're just going to do it manually until the end of time, or we're going to use LLM that have absolutely unknown accuracy or whatever, and we're going to end up spending more time creating the LLM-generated data than creating from scratch. So I totally agree. We should focus on the process of building those databases.
Yeah, creating a community, a resource which is easily searchable for data and models both. I don't know what the answer is to that. I'm just reiterating the problem.
That's a nice dream.
That is a great dream.
All right. Anybody else? Because yes, go ahead. By the way, before we can go forward a little bit more. I want to say a big thank you to Belle that helped us. Hey, Belle. Thank you to Elise that also helped behind the scenes. Elise. And thank you to Pablo, who also organized very nicely the conference. Yeah, Pablo. And now the conference is on, but we can continue the conversation. Go ahead. Let's go deeper downstairs. Yeah, nice. There is? Yeah. Downstairs is a bar. Okay, let's finish this because otherwise people will finish here. Yeah. And then we'll go drink.
Yeah, I just go fast. I think that there's two things in my comments. First, about the accessibility from the participant, because when we do the modeling, we also have lack of resource or something like that. But for LLM, we probably think it's pretty hard for people to train the model. But anyway, for example, like in GPT-4, like many apps actually built on top of it simply by creating the prompt techniques, like one-shot, like chain of time, and so on and so forth. But I think this is a room for if you want to create a challenge for that. I mean, people don't need to train a model, but they can craft their own way to for the prompting techniques. The second is the
challenge would be what can you build on top of this?
Yeah. So you just need to provide the API, for example, using Llama 2 for something like that, and all they need is just to create a framework of prompt to try to something. And the second comment, I just try to be fast here. So there is a paper from the Microsoft. It's actually related to causal reasoning, and I think I kind of inspired from this about your questions, which is they use a benchmark data set. This benchmark data set is simply to ask LLM to ask about causal directions, because we cannot answer causal direction using only data. So I try to think about, for example, we only have, for example, a mechanism from the KAGG, right? In KAGG, the direction is clear, so we can use the data. But I would say KAGG itself is not enough. Like I would prefer like something bigger, like probably gene ontology. But gene ontology or like I forgot the another one also, like a network. But it's not provided like a KAGG with a clear direction. I would say if there is a data set that we can provide about the direction, about this causality, for example, and then people can use that to make either whether they can train a new LLM model, or they can have a new prompting techniques to do so. So people can reuse that multiple times, something like that. But it just simply direction, because it's not something that the analysis can do.
The directionality of the
Yeah.
So they call it retrieval augmented generation, right? So
Yeah.
the idea that you're just having to have a source of data that you can add to your prompt to send it back to the LLM. And again, you have a problem that people are expected to solve using ChatGPT, right?
Yeah.
And what's that problem that, people are supposed to get it accurately right and leave this biomedical field where we are, right? Because if they are asking for how the weather is going to be or how to build an assumption in their house, how is it relevant to us, right? So I guess the first question is really, what is that thing that you should be doing with LLMs that, a reasonable person would do it as opposed to having the dedicated tool, whatever that is, a database model, whatever it is, right?
Yeah, I think it's more like high-level information, something like that we can predict using LLM.
All right.
Sorry, just I think it's worth.
Last word.
Look out for. I just remind myself an initiative called Our Future Health or something like that. This is starting in the UK. That is national scale health registry, and they are sequencing a lot of people and collecting blood samples and things like that. No, it's something new. It's something different. So no, it's not. It's something new. This is coming up not only now, but the size of the data set is probably relevant for this kind of models, because the data is the main limitation, I still believe.
All right, everybody. Thank you. Thank you.